Hello, and welcome to Robert's Robotics, formerly Robert's Tech. Yes, we're changing our name for better functionality online, make it easier for everybody to find us. So from now on, the website will be Robert's Robotics, www.robertsrobotics.com. Okay, and this is part 3 of this chassis build. Finally, it's got wheels on it, and I added a robotics arm, which we'll talk about. I've got a couple more boards on here. I've got a servo driver and another motor driver, and a lot more wiring. The last video I had most of the power wiring done. Now all the power wiring's done, and we'll see it powered up and running today. I've added some wires to the Mega board over here. A lot of wires to the Arduino. It's actually a Leonardo. So things are actually up and working now. Although right now I've just got test code in there. I have no navigation sensors yet. I've ordered some, and I'll probably use a combination of some of the simpler LiDAR sensors as well as possibly some of these ultrasonic ones. So that still remains to be worked out. But for now, I just want to show you what I've done since the last video. So let's start with the wiring that I've done since the last video. I have more power wiring. In fact, a lot of 5-volt connections here. On this build, I used 5-volt processors, and most everything's running on 5 volts. So I decided just to go ahead and make my distribution board all 5 volts. Normally this board is split up into 2 circuits, and so you could have 5 volts to 3.3, but I'm just going to jump it all to 5 volts. That gives me more connections for all the different 5-volt boards that I have. I still have 3.3 available here. If I add something, I can still tie that in. So more power wiring. I finished the motor driver wiring here with my adapter board going to my drivers. And also I have finished the connections here to the Arduino for all the signals that are driving the motor drivers, the relays, and also our extra board here. The other thing I added was the servo driver. I've got all the power wiring. I've got the communication wiring in there. It's not functional yet. I haven't written any code yet for that. So I'm not going to run the arm today. I will run the gripper because I have the gripper hooked up, and you'll see that operating. The biggest change, of course, is the wheels. Got the wheels on here. Swivel wheels in the back, one on each side, and large diameter driver wheels up front. And you'll see it again. We'll have it running in a few minutes here. So the main thing that you want to notice about this whole build is that I've really laid things out to try and make the wiring as direct as possible, and so far it's all working out good. I made more of my little adapters here so that I can put the wires into screw terminals. As I said in the last video, this one I bought. You can buy these little screw terminals to plug in. I didn't see one for the Mega, so I just went ahead and I soldered some screw terminals to the pin headers, and it works out real nice. Right now, the communication for the servo board is on the I2C bus, and I've just got it wired directly to those pins on the Mega. If I were to add another I2C board, I'd have to split that out. And so in the future, I may add one of these hubs where it allows you to split it off into a bunch of different devices. The other thing I might do, well, as mentioned, I may put in some ultrasonic sensors. I still have this area here for those types of things, and I can always put one in the back here. The other thing I might do, and I've done this before with robotic arms, these little infrared sensors are nice for close proximity detection of things. And I may put one of those up in the arm to detect that there's actually something in the jaw, and that kind of helps you know when to close the jaw. Ultimately, this robot is going to be used probably just for experimenting with retrieving items from different rooms. The arm itself is very simple. It's only 2 servos, so it's able to lower and raise the arm while keeping it parallel to the ground so you can pick things up. I bought these kits online. I forget, Amazon or eBay, I don't remember which one, but it comes with the servo and these two brackets, and that's the whole kit. So this is two kits, and I just combined them together. Then this gripper is actually a make block product I had laying around, so I decided I would use it. I had to build an adapter plate since these are two different manufacturers. The holes didn't line up. So I drilled a little plate of aluminum here to adapt that on there. The next thing I added was this extra motor driver board, because this robotic gripper uses a standard DC motor. It's not a servo. So in order to make this gripper open and closed, you have to run the motor forward and reverse. So I just added another board to do that. So it's just the one output going to that motor, and I'm controlling that over here with the Arduino Mega. So it just runs the motor one way to open the gripper and another way to close the gripper. Now, of course, the servos will have to have a servo driver, and so we have that board. And I've got plenty of extra connections here for more servos if I decide to, put more servos on the arm. But I think for what I'm going to do with this rover, this is going to work out fine with just the two servos. And, it's a lower cost, simpler way to do something like that. Some of the larger arms can get pretty expensive, and for what I'm doing, I just don't need all that extra movement. If I want to move the arm left to right, I can just rotate the robot like that to do that, and then I can raise the arm up and down. Other arms have the ability to rotate the gripper. I'm just not going to have that. Again, I just want to pick things up and be able to transport them to a different location. I think this is going to satisfy that requirement. So quickly, let's review what I've got here in the power bay, and then we'll put this thing down on the ground and we'll run it. Again, it just has test code in it. It's just going to run a little exercise that I programmed into the Leonardo, and then the gripper will open and close based on some simple code I have in the Mega, and that's all it does right now until I add more sensors. But just quickly to review what I have here. This power board I bought online. It was a little hard to find. There was only a couple places that had them, and they didn't have very many of them. It's a nice little board that puts out a variable voltage, which I have this connected to my servo driver here. So I've got it set for 6 volts. Most servos will run anywhere from 5 volts to 8 volts, but 6 volts is sort of the standard servo voltage, so that's what I've got it set to. I did end up using my 12 volt, low current 12 volt output tap, which I ran up here to my extra motor driver board, which runs the gripper. So that is a little modification I did to this board to give me a low current limited to 1/4 of an amp at 12 volts. Then I've got my 5 volt output, which is run to my distribution board, and that's split out to all the things that need 5 volts. And then I've got a 3.3 volts that I'm not using right now. The relays again are in here to switch my motor drivers on and off, and to switch my servo board on and off. And that's just there in case I want to try and save some energy on the battery. I can shut those down if I want to. This board is something I built myself, and that's just to adapt these plugs to these screw terminals. And I did add LEDs just to show that the power's on and which direction the motors are going. This board here is just to absorb any spikes that may come from the motor drivers, to try and protect the Leonardo from spikes from the motor driver. And again, that's a little board that I made myself. So next is to turn it on and let it run through its exercise program, and you'll see what it can actually do. Okay, so now it's running its exercise program that I've coded in, and it's just gonna go one way, turn around, come back the other way, and the gripper itself is just opening and closing, but it just shows how it moves and that we actually have made some progress here. The rover is moving around. So next step will be adding sensors so that we can navigate. Not sure exactly what it's all going to end up having. It may have a camera, LiDAR sensor. Just to review, what you're looking at is a chassis that is available at robertsrobotics.com. And at the beginning of the video, video number 1, it had the bare chassis pretty much, and we were looking at the layout. And in 2, we started actually mounting everything and wiring things. So this is a conglomeration of different boards that I found on the internet, along with a battery that I bought at a local battery place. It's a standard sealed lead acid battery. Wheels from, I think I got these wheels at Servo City. And so this is something that anybody can build. You just got to search around for the parts. Of course, Arduinos, everybody's familiar with those. And the code I wrote is very basic Arduino code to just simply run the motors and the gripper opening and closing it. Well, I hope you enjoyed this video. This is quite the project to work on, and next time hopefully we'll have some sensors and it'll do something a little more intelligent. Be sure to visit us at www.robertsrobotics.com, and we'll see you on the next video.